Hi there. Let me take a few minutes to discuss the second of the AP practice questions. So this question actually was on half of the quizzes that you might have taken over Chapter 5 over designing sample surveys and designing appropriate experiments. Most of this question, this is actually a four-part question on the actual AP exam. Three of those four parts were one of those quiz questions that, depending on what version of the quiz you took, you've already seen this question. This is the fourth part of the question that I didn't include because it wasn't a calculation we were ready to do yet. So this is about a survey to be conducted to determine the educational level of adult head of households in the United States. So each survey participant will be included into two categories. Either they do not have a high school diploma or they have a high school diploma. It's going to be done with a phone interview using random digit dialing. So recognize then a pilot survey. So what a pilot survey is just a very small survey to get some idea about what the actual, just to get a first shot at what that sample proportion might look like. So it's a small survey. It is not a super sophisticated survey. It's just to get an idea of what a sample proportion might look like. And so here's the sample proportion that they got, 0.22, 22% of the population of adult head of households do not have a high school diploma. So using this information, how many respondents should be attained if the goal is to estimate the proportion of the population who do not have a high school diploma to within 0.03, so that is the margin of error that you're given, plus or minus 0.03 with 95% confidence. So when the question says justify your answer, that means you need to show your work. So here is the way we would build the expression for the margin of error for sample proportions. I would hope that you would recognize at 95% confidence, this is the appropriate critical value, the appropriate z-score. Again, you can use the inverse norm command on your calculator. Second distribution's inverse norm, you want to put in 0.975. So because this is a proportion, we don't have to worry about degrees of freedom. So 1.960 is the appropriate critical value, so there it is. So my margin of error is plus or minus 1.960 times the standard deviation of the sampling distribution. So that is the square root of p hat times 1 minus p hat over n. So the pilot survey gave us a p hat of 0.22, so there it is. There's 1 minus 0.22, and it's divided by n. So the margin of error is built using the critical value, and then this is the standard error or the standard deviation of the sampling distribution. And we want to find an n so that this margin of error will be less than or equal to plus or minus 0.03. Of course, to do the actual solving, you can just set this expression equal to 0.03. You don't have to worry about the pluses or minuses. So what I've done, I've already divided both sides of the equation by 1.960, and I've also already squared both sides. So there's the 0.03 divided by the 1.960. And to get rid of the square root, I squared both sides. And again, like I already mentioned, I just went ahead and changed it to an equation. So very good then. I did go ahead and do as we had described in class. I did this calculation. I actually did this calculation and rounded it off so I could write it as a proportion so it'd be a little easier to see the cross multiplying. So the 0.1716 times 1 would have to equal the 0.000234 times n. So you can divide by the 0.000234, and that will give you a sample size of 733.3 repeating, I believe is what I got in my calculator. Of course, remember, in order to get the correct margin of error, though, you must always round up. We can't have 0.3 repeating. We can't have 1/3 of a subject in the survey. So 733 by itself is not quite enough to get the correct margin of error. So I've got to round up to 734. This is just off by 1 or 2 digits due to the rounding. And of course, because you've shown your work and you've justified your answer, in fact, you wouldn't lose any credit on the AP exam for this. The key is to justify your answer and then actually show your work to show how you got to that calculation. So real quick here, let me see if I can find the actual value real quick. 0.22 times the 0.78 divided by 0.03. So yes, on the AP rubric, they actually stated in the answer of 733. They had to round up from 732.4.